Hi everyone, we're gonna go over we're gonna continue with IM2, and in this video we're gonna do chapter 3, which is mostly probability, and then going more into trigonometry and stuff like that. So we're gonna start off with probability, and we're gonna use models to explain or kind of demonstrate how I guess basic probability works. And the easiest or the most common form of probability everyone's probably seen before is a coin toss. So we know that there's two sides. Let me write this. There's a head side and then there's a tail side. So if you flip it once, the chance of you getting a heads and the chance of you getting a tail is each 50% or half, because there's two sides, one option. However, there are more complicated versions of this, I guess, problem where you choose a specific case out of the total number of chances that you could possibly have. And for example, using the same idea of a coin toss, a question is, what's my probability of getting two heads and one tail in 3 rolls? I forgot to add 3 rolls part. So when we do something like this, we can use something called a tree graph, which is what I have over here. It kind of shows you the total possible paths you can take from your initial decision or your initial result. So that's what I'm gonna explain how the tree graph works, how we do it. So this is the origin, or where you start. Your first toss, let's say this whole row is your first toss. I can either get a heads or I can either get a tails. I have no other option. And next, if I get a heads and I flip again, my options are again, so this is my second roll. My options again are a heads or a tails. And if I get a tails, my options are a heads and a tails. And the same thing happens for the third roll. Oh, shoot. Give me a second. I will cut this out. My computer's about to die. Okay. And for the third roll, I have the same options again. So third, I could either get a heads, tails, heads, tails, heads, tails, heads, tails. Now, what I'm highlighting in blue here, is just one of the paths you can take for 3 total coin flips. So I can get one head, another head, and a tail. That is one possibility. The question asks, oh, and all of these different paths is one specific path you can take. So what's my probability of getting 2 heads and 1 tail? We're not counting order in this case. We just want a total number of 2 heads and 1 tail. So let's see how many we can get. If we start off with a heads, we only need one more. Well, we need one more heads exactly. So we can't go to the path where it says 3 heads, so that's out. We can go to this one, which leads us to a tails, so that's 1. Or we can go to this tails, and then which leads us to our second heads. If our first roll is a tails, however, we have to get 2 heads in a row in order to get 2 heads. So our only option, if we get first roll is our tails, we go heads, and then our third roll is a heads. None of these other options will work because it doesn't apply to the question. And then something else we can consider is kind of choice probability, which a good example is, for example, this person, let's give her name Sam. She has a choice for the meal she wants to eat, and she has a choice of mains, either a meat or vegetable, a choice of sides, a meat, a vegetable, or a type of bread, and then a drink, so water or juice. And a question could be, what is the probability that Sam is going to have a vegetarian meal? So we know vegetarian implies that there's no meat. So our options are always going to include the route, I guess, the path, where we choose vegetable. The next one we choose vegetable or bread, and then either one of the drinks will work. So a question you could ask is, because probability, as a fraction, we want to write total options over optimal, or what we want, optimal options. what is our total options? Well, we have to multiply together and then add the all the variables. So in mains, I have 2 options. And then in sides, I have 3 options. And in drinks, I have 2 options. So 2 times 3 times 2, which is give us our total number of combinations, just like how you would think of it in the coin flip, will give us 12. So our total options is 12. Optimal options. We want 1. We always want vegetables, so 1. We can either get vegetables or bread, which will give us 2 options. And then either of the drinks will work, which will give us 2 options. 1 times 2 times 2 will give us 4, which can be simplified to 1/3. So that's the chance that Sam will have a vegetarian meal. Kind of coming to a close here, we have probability through pie charts. So in this question, we want to ask, what's our probability of getting an amount greater than $10? So let's say you're at a game show, they spin this red arrow, and then wherever it lands is the amount of money you get. And you want a value greater than $10. So let's see what values are greater than 10. So we have 100, and then we also have a 50, and that's it. We said greater than 10, so just the $10 doesn't count. And assuming, well, I tried to draw it this way, but assuming that all of these portions are equal, or this is divided equally, and since we have 6 pieces, 6 equal pieces, the chances of us getting a value greater than 10 is 150, 2 options, and total of 6 equal options, which can simplify to 1/3. However, our pie charts won't always be even or equal. So we have to take in a case where our pie charts are going to look something more like this, where there's going to be maybe a fourth and another fourth, and then these are all 1/6s. So in this case, we'd have to you'd have to take the individual probability, like relative to the area that this slot takes up, in order to keep it consistent. We didn't have to do that for this because each thing is equal, each piece is equal, but this is, you just have to add the extra step of multiplying by this 1/4 in order to find the actual probability of something landing on this, like arrow landing on this side.
All right, hey everyone, I'm Oleks, and I'll be talking about slope ratios, angles, and the tangent function. So the first thing we should probably talk about is the slope ratio, which is delta y over delta x. And you probably heard of this before, but the point is that every line has this slope ratio. And the way we can find it is we can draw a triangle on the line from any 2 points, and we just divide the delta y over delta x. And any triangle we draw will give us the same answer. So let's try to see how this is true. So I have a graph here. This is a y equals x graph. So let's figure out what the slope ratio is. By the way, before we do this real quick, so delta y just means change in y, and delta x means change in x. So this little triangle sign means change. Okay, so let's pick the point 7, and point 3, and then draw a triangle, which I already did here. We can see that the change in y is going to be 1, 2, 3, 4. And then the change in x is also going to be 4. And delta x over delta y is just going to give us 1. So we can label this triangle as having a slope ratio of 1. Let's go to another triangle over here. Maybe this one. And let's do the same thing. So change in y is 3. Y goes up by 3. Change in x is also 3. And then same thing. Change in y over change in x is also going to give us 1. And you can try this yourself, but any triangle you draw, as long as it's on the line, will always give you the same slope ratio of 1. So if we go up, there's a couple of sample problems here that we can practice finding the slope ratio. So let's look at the first problem. So we can draw a triangle right away. We can draw like a triangle here. And we can draw maybe a bigger triangle here. So imagine this is 2 triangles, so the bigger one and the small triangle inside. The smaller triangle has a change in y of 1, 2, 3, 4. So we can see that this is 4. And a change of x of 1, right? So we just have 4 over 1. So Our slope ratio is 4. And let's just to make sure that it is 4, let's try the bigger triangle. Y goes up by 1, 2, 3, 4, 5, 6, 7, 8, and goes to the side by 2. So 8 over 2 is also 4. So you were right. Now let's look at problem 2. Now problem 2 is a y equals x graph, and as we have already done, we figured out that any triangle that we draw will just give us a so right here we can draw this one, will just give us a slope ratio of 1. 3 over 3 is 1. Let's look at number 3. And if you notice, when I'm drawing these triangles, I'm picking the points where the line is a whole number. And this is because it's much easier to measure the size of the triangle. So right here, I notice that here's a whole number in here, and I can just draw the triangle. And the triangles themselves, again, they don't matter. The slope ratio is always going to be the same. So here the triangle goes up by 5 and goes to the side by 3. And change in y over change in x is the slope ratio, which gives us 5 over 3. And we can try another triangle. So maybe we'll try one that goes from here all the way to the end of the line. If we notice, the triangle goes up by 15. So you can pause and count, and it should be 15. And then it goes to the side by 1, 2, 3, 4, 5, 6, 7, 8, 9. So that gives us a slope ratio of 15 over 9, which just simplifies to 5 over 3. So it's the same slope ratio. Now let's look at the last slope ratio problem. So again, we can draw a triangle. And it goes up by 1, goes to the side by 4. We can just label it as 1 over 4 as our slope ratio. Okay, so how is this slope ratio any useful? Well, if we go back to the original problem, it's a little bit easier to see.
Wait, what?
Wait, could you zoom in on the original graph? Or just have it like be in the center?
This one?
No, the one at the start.
This one?
Yeah, that one.
Okay.
All right, thanks. So if we know the slope ratio, we can actually calculate this angle. Let's call it theta. And the way we do that is we use the tangent function, which you should see a tangent button on your calculator. And I'll show you how right now. And just to add, if you're wondering, if you have a line that goes like from positive to negative, then you do the same thing, except this time, obviously, change in y would be, you keep it as positive, and you would just, if you were to use this method, you would just get this angle theta. So it's pretty much the same thing. But anyways, let's go back to here. So if we remember, the slope ratio we found was 1. And the key thing to realize here is that tangent theta, so the tangent function of this angle, will equal to change in y over change in x. So for now, this is just something you have to memorize. And we know this is just a slope ratio. So let's test this out. If you go into your calculator and you plug in, I believe it is 45 degrees. So make sure your calculator is in degrees mode. I mean, you can't see my calculator, but if you do tangent to 45, you should get 1. So we know this angle is 45 degrees. And we can actually use this to solve triangle problems. So if we go to the side real quick, to the triangle problems I have up here. Let's start with B, because it's a bit easier to imagine. So if you can imagine a line kind of going here. And this triangle is a slope triangle, this line. And we know that the slope ratio is going to be 22 over W. And if we remember from the formula, tangent of 20 is going to be 22 over W. A good way to remember it is that it's the opposite side over the adjacent side, or the, it's better to think of it as a line. So, right, you have change in y over change in x. So we can write that 22 over W is equal to tangent 20 degrees. And we can use this to solve the equation after we move some of the variables around. So 22, so let's multiply both sides by w is equal to w tangent 20. And make sure this is degrees. And we can divide both sides by tangent to kind of get w by itself. W is equal to 22 over tangent 20. So now just plug this into your calculator. 22 divided by tangent 20 is going to give us 60 with some fraction. Specifically, it's going to give us 60.445, and then we'll just round it there. So that's W, and based on the picture, it does look right. So now let's go to problem A. So with problem A, it's the same thing actually. You look at the rise, side opposite of the angle. So you can imagine this thing as a line, kind of goes on that way. So the rise of the line is Q. So we can say that Q over 9.6, which gives us the slope ratio, is equal to tangent of 62. So this is, again, using the formula that the tangent of the angle is equal to the slope ratio. And after multiplying both sides by 9.6, we get that Q is equal to 9.6 times tangent, times tangent 62 degrees. And again, we can plug this into a calculator and we get Q is equal to, let me plug this in real quick. Around 18. We'll just round it there. So we do the little round symbol. So yeah, that is how you can use this angle to find the missing side of a triangle, if you know the angle. And this only works for right triangles, because if you notice, if you go back to the graph, we see that all the slope triangles in this line have a right angle over here. So this method of using the slope ratio only works for right triangles.